All right, workout problem 1 for lesson 27. So we're trying to find the net torque on this disc. The radius of the disc is going to be 3 meters. So if we just use our torque equation, torque equals R cross F. All our vectors, once again, the other way we can write that is RF sine of theta here. So we want to do the net torque on this disc, so we need to add up all of the torques. So we'll say that this is going to be torque 1, torque 2, and torque 3. We need to take into account all of those on this disc. So if we start with torque 1, that is R cross F, or RF sine theta. So our R, we know that the radius of the disk is 3 meters. So that's going to be consistent for all of these because we know that at the end of the disk, or at the edge of the disk, is where all these forces are. So all cases, the R is going to be 3 meters. So we know it's R, F, and then we have sine of theta for 1. So R is 3 meters. We have our F, which F1 tells us that it's 10 newtons. So we have 10 newtons, and then the sine of 90 degrees there. For torque number 2, once again, RF sine theta. So R is 3 meters. Our force is 10 newtons, but our angle between those two is going to be 0 degrees because we are going in the same direction. So the sine of 0 is 0, and this whole thing then, so for the torque of 2, it's going to be 0. Now if we look at torque number 3, we've got a RF sine theta again. So our R is 3 meters. Our force is 10 newtons. And we have a sine of some angle in here. And the angle, right, we want to know the angle between these two. So we need that angle there. So that would be 180 minus 120. So that gives us the sine of 60 degrees. Now, the other important thing to know is in all these cases, torque is a vector. So we need to know, is it going in the positive or the negative direction? So we use the right hand rule, and we point our fingers in the direction of the radius and curve them in the direction of the force was going to give us the positive direction. However, all of these forces, with the exception of 2, because it's parallel to the radius, go in the negative direction. So we're going to have a negative on torque 1, we're going to have a negative on torque 3. So when we add these up, here we go. So the sum of all these torques, so we want the net torque, so the sum of all the torques, we're going to add torque number 1, which ends up being negative 30 Newton meters, and then we're going to subtract off 25.98 Newton meters, or about 26. So if we're looking for the net torque on that disk, we supply all of that. So our net torque on our disk, looking down from the top, is going to be negative 55.98 Newton meters.